Here, what we will do today. An STM32 microcontroller talks to the BMI270 IMU sensor to receive accelerometer and the gyroscope data. In this tutorial, I will guide you through every step to make this happen. Wiring, SPI initialization, IMU configuration, and finally receiving the accelerometer and the gyroscope data. By the way, if you are interested in working on awesome projects, be sure to check out my Balancing Robot course on my website. In this course, I will guide you step by step from scratch to a fully functional robot. For that purpose, we will cover embedded system topics, motor control, using an IMU sensor for the attitude estimation, and finally control system topics. And the most important thing, I will show how to combine all these fields to build a fully functional robot. The link is in the description. BMI270. It's one of the most popular IMU sensors nowadays. Besides providing the accelerometer and the gyroscope data, it has advanced features. Motion detection, the gesture detection, and counting the steps. Considering all these advanced features, I decided to make a series of tutorials to build a library from scratch for this IMU sensor. So in this video, we will only focus on receiving accelerometer and the gyroscope data, but then I will cover how to get these advanced features as well. So in this tutorial, I'm using a Nucleo L476 board, as you see here. So for this microcontroller, I created a project, and here I have a IUC file of this project. So as I said, we will use SPI interface to communicate with the sensor. So first thing, we need to configure the interface. So within connectivity, I chose SPI2, and here I use full duplex master mode, and the configuration, the parameter settings, everything is default values except the prescaler. So I set 16 to have 5 megabits per second, and the rest, clock polarity, clock phase is low, and first edge. So everything is default parameters. There's nothing much to say about the SPI interface. And also for the SPI interface, we need a chip select line. So for that purpose, I'm using PB1 pin. So here I configured it as GPI output, and I gave this symbolic name, SPI2 chip select. Next thing, we of course have to connect the sensor to the microcontroller board. So for that, we need to go to GPIO settings. So here we have PB13, 14, and 15. So we need to connect these pins to corresponding lines of the sensor, and also don't forget the chip select line. And in this specific video, I'm using this BMI270 board from Sparkfun. So here I have the schematic of it, and the most important thing about this board is that you have to remove these jumpers, these connections. You just have to scratch them to remove the wirings, otherwise it won't work. So I spent just one day to figure it out. So don't forget to remove these connections on this board to use the SPI interface. Next, let me show the library I created to work with the sensor. So here we have the header file of it. First thing, as usually, I created the symbolic names to define different registers of the IMU sensor. So for that purpose, so I get all this info from the datasheet of the sensor. Then I have another struct to define the IMU data. So we have the accelerometer data, then we have the gyroscope data for each axis. Then we have another struct for the sensor itself. So here we have the members to define the chip select line. Then we have the SPI handler, and finally we have the IMU data. Next, let me show the source file. So here we have the functions to activate and deactivate the SPI line. For that, we need to reset and set the chip select line correspondingly. Then we have another function, I think a quite important function, to write to the SPI. And here I can do sequential writing, meaning that I can update the values of several registers in a single write operation. So in this function, of course, we need to send the offset register, and then we can send the data. So example, imagine that I define offset register as 10, and if I send 3 bytes, I will update the registers 10, 11, and 12. So this offset, this argument defines the offset register, the first register we want to update, and this data size defines how many registers we want to update. Similarly, we have another function to read the register values. So here again we send the register, but we have to set the most significant bit indicating the read operation. Then we read 1 byte, but this byte is useless. It's just a dummy byte, dummy data, so I just ignore it. Then we can read the data. So again, the example, if I send 10, but of course we have to set the most significant bit, so we do the read operation, but for this example, imagine we will just ignore it. So we send 10, and if we read 3 registers, we receive data from 10, 11, and 12. So these registers, so we get the data from these registers. So let's move on and let me show how I initialize the IMU sensor. And to initialize, I use the datasheet extensively. So the first thing, before initializing, we have to make sure that SPI is working, that we did the correct wiring. So for that, we just need to read the register 0. And if we receive this value 24, then the communication is fine. So I will do exactly the same thing here. So I read register 0, and I compare, like if it's a 24 or not. If it's not, I just return this error. Otherwise, I will keep moving. And the next thing, I do soft reset. So I will set default values to all registers of the IMU sensor. So for that, I use this register 7E, and I have to write this value B6. Then I just toggle the SPI, the chip select line to activate the SPI. Next, a very important step is to update the configuration file. So unlike in other IMU sensors, there is a configuration file we have to write to the specific, starting from the specific register of the IMU sensor. Otherwise, it won't work. So by configuration file, I mean a huge chunk of data. To be specific, 8 kilobytes of data. So I have this array, and I have to send this data to the IMU sensor. And I get all these values from the official GitHub page of the IMU sensor. You can find it in the link in the description of the video. So to send this array to the IMU sensor, I created another function, write config file. So let me show. So I did all these operations. So first I write 0 to this register 7C, which is just over there. Then I need to write to this register 0. Again, it is just over there. Then I have to send the configuration file to this register. So we do burst write, which I'm doing just over here, and we have this amount of byte. Then we write 1 to this register 59, which I'm doing just over here. So after configuring, we can check that initialization is done correctly. For that, we need to read register 21, and we have to receive 1. Otherwise, something is wrong with the initialization sequence. So I do it just over there. We receive and we check whether the value is 1 or not. If not, I return this configuration file error. Otherwise, we will move to the next step. So the next step, we have to configure. So I use normal power mode, and I do all these operations. So I think it's pretty redundant to explain all of them. So I use exactly the same sequence, which is just over there. So after all these operations, the IMU sensor is ready. So to read the IMU data, accelerometer and the gyroscope data, we have to read starting from this register 0C, and we have to read 12 bytes. So let me show how I do it, but it's a separate function for me. So here we have a 0C, we receive 12 bytes, and every axis data is a short integer number. So we have to do some tricks to get the data. So we have to combine we have to combine 2 bytes to get the value for each axis. So that's what I do just over here. So first we get the accelerometer data, then we have the gyroscope data. And finally, let me show how I initialize the sensor. So I define, and of course we have to include our library. Then we have the IMU sensor. Here I define all the members. So we use SPI2. We have these pins. You have this pin, chip select pin. So these symbolic names you can find within main header file. Then within the main function, I initialize the sensor. But here I'm not checking the error, which you could do it to make sure that the IMU sensor is working well. Then I read the IMU sensor, and I use just the one dummy data to plot the received data. And I do it every 10 milliseconds. And of course, it's not the best approach. I think it's better to use timer interrupts to do this operation periodically. But of course, we will do it later. Maybe in the next video, I will use timer update interrupt. Also, maybe I will use the DMA to make the communication more efficient. But for the demonstration, this should be enough. So next thing, let me debug just to show how things work. So to plot the data, I use this variable. So I have a serial wire viewer timeline graph. So if you don't know how to configure this tool, you can refer to my another video on my channel. So here I define the variable I want to plot, accelerometer copy. So let me start. Then I use some breakpoints just to check that everything is working, but you can ignore it, of course. Then, as you see, we are receiving the data, and also we can use live expressions just to make sure that we're receiving the data. And as you see, everything is updating in real time. And if I shake, you can see how the plot is changing accordingly, meaning that everything is working well. For the final note, I want to mention that the source code is available on Step School organization on GitHub, so you can get access to the source code of all projects I've worked so far by becoming the member on my Patreon community. So once you become the master engineer member on my Patreon page, you automatically get access to all these source code, all the projects I worked so far. So that's it for today. Please don't forget to subscribe to my channel, and if you have any questions, I will be glad to answer them. So see you soon.